In the early 1900s, documents and cash were delivered through a system of pneumatic tubes. Today, these tubular systems still have a place. Hospitals rely on them to transport blood samples to labs in seconds. For patients in need of a quick diagnosis, these pipelines can be a lifeline. Behind the walls of many hospitals, there are pneumatic pipelines that can be several kilometers long. Healthcare workers seal blood and other medical specimens in capsules and put them in the system. A computer allows users to monitor the movement of the capsules as compressed air whooshes them through the tubing. They travel to the lab with gale force speed, arriving in seconds. To build a pneumatic delivery system, they start with the send and receive unit. A worker glues tubes to a plate. Both are made of plastic to reduce static. He slots the tubes through holes in the top of the unit's metal housing. He places more tubing inside the housing and installs a track for it to move on. The tubing slides back and forth beneath the top two to shift between send and receive mode. He screws a bracket with a motor for the sliding mechanism to the box. He then moves the unit into an upright position and connects the motor to a power source for a test to confirm that the motor moves the plastic chutes back and forth smoothly. He connects an air source to the system to verify that the seals and vents work properly. Transferred to the next station, a technician removes the door that was installed temporarily and then wires the motor to the electrical power source. He bundles the wires and trims the plastic ties. He fits the computerized control panel in the door and screws it to it. He reattaches the door, wires the control panel, and then verifies that it works. Next, he connects the computer in the send and receive unit to one in a diverter unit. He confirms that the two computers communicate. There are numerous diverters in a pneumatic delivery system. These units allow the medical capsules to turn a corner or change directions within the system. He installs a motor and gear and tests the movement of the pipe from one outlet to the next. Satisfied that it's functional, he screws the back panel on. Then they connect the diverter and other transfer units to tubing in the walls of the hospital. To make the delivery capsules, a worker places the plastic body in a fixture. He activates a device that spins a lidded cap onto it. The spinning also generates heat that fuses the cap to the body. He slides the capsule onto a post. This keeps it from rolling around as he hooks one end of a spring to the lid framework and the other end to the sliding lid. With the spring in place, he screws the sliding lid to the framework. The lid now springs open and shut like a spring door. He snaps rubber casing onto the end and stretches a rubber gasket around the rim. He wraps fabric bands around both ends to help buffer the capsule during its journey through the pipeline. He tucks them into the rims using a screwdriver. He installs plastic bumpers inside. They'll help buffer any knocks to the capsule and its contents during the ride through the pipeline. This medical capsule is now ready for a test run. The technician inserts it in the chute and programs the journey. He opens the door to reveal the operation to our cameras. The tubes slide over to collect the capsule and then slide back to drop it into the main pipeline. Compressed air blows it through the system, and it's gone with the wind on the way to the lab.